Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. And today we're going to learn about implicit differentiation. And for each problem, we're going to use implicit differentiation to find dy dx in terms of x and y. So, if I was given this problem, 2x to the third equals 2y squared plus 5. Well, if I want to do this, what I do is on the left-hand side here, I treat 2x to the third just like I normally would. I would kind of ignore this and say, okay, power rule as 6x squared. But on the right-hand side, I'm going to do the same thing with y for the beginning part. But it's kind of like, think about a chain rule here. 2 times 2, all right, power goes down, 2 times 2 is 4. Y, we subtract the exponent by 1, so y to the first power. But now we want to multiply by the derivative of the inside part, that y. It's kind of like where the chain rule kind of is similar there. The derivative of y is dy dx, right? Y is a function, so we're deriving that with respect to x, and so it's some new function, the derivative. Now, the plus 5 is pretty simple. It's a constant. It's eliminated. It's just 0, right? Don't need to write that plus 0. So now I'm pretty much done with the calculus. I just need to get dy dx by itself. So to do that, I'm going to first divide by 4y to both sides. So we kind of divide by 4y here. And then I'm going to put dy dx on the left-hand side. I like that. And then so I have now 6x squared over 4y. Now we can easily simplify that. I'll put it right up here. Simplify that. 6 over 4 is really 3 over 2. So we have dy dx here is equal to 3x squared over 2y. And there we have, my marker, hold up, our final answer. 3x squared plus 3y squared is equal to 2. Well, what I want to do is I take the derivative here on the left-hand right side. I'm going to treat x just like I normally would x. Power rule, 2 comes down to 3 is 6. So 6x, subtract the exponent by 1. So it's 6x to the first power. I'm going to do the same thing with y. Pretty much exactly the same that first part. 2 comes down, times 3 is 6. Y, subtract the exponent by 1. We have the first power now. But now I need to multiply that by the derivative of y. The y value, since we're finding dy dx with respect to x, right? The y one is kind of like a chain rule. We have dy dx. That's the derivative of y. And that's equal to, well, 2. Derivative of 2 is just 0. So now my goal is just using some algebra to get dy dx by itself. So subtract the 6x at both sides. Dy times dy dx is equal to a negative 6x here. Then I divide by 6x to both sides. Dy dx is equal to, well, negative 6x over 6x. This one can simplify, 6y. Whoopsie, there's a common mistake you can do right there. 6y. Okay. Now, the 6's basically cancel out. So we have dy dx here is equal to negative x over y. And that is my final answer. 5y squared equals 2x to the third minus 5y. Well, what I want to do now is I want to get, or take the derivative here, and I'm going to treat basically every variable like it's an x, except for the y's, right? The y's will have one extra step to it. So 5y squared, well, power rule says 5 times the 2, 2 comes down, we have 10y, subtract the exponent by 1, 2 minus 1 is 1, times, now y is just dy dx, the derivative of y. Go to the right-hand side, power rule here, 3 comes down, times 2 is 6, 6x squared, all right? We don't do an extra step for the x's, minus, well, 5y, well, derivative of 5y is, well, minus 5, derivative of y, 5 is a constant, y being derivative of y, dy dx. So now my goal, when we think about this, we have to get dy dx by itself. So what I'm going to do is I'm actually going to add a 5 dy dx to both sides. So I have 10y dy dx here, plus 5 dy dx. That's equal to 6x squared. Now, I have a dy dx right here for both parts. What I can do is I'm going to pull out a dy dx outside, and that leaves me with a 10y plus 5 on the inside, equal to 6x squared. So now, what I want to do when I finish this, right, I'm going to divide by 10y plus 5 to both sides, leaving me dy dx. So I have dy dx here, right there, is equal to, well, that's 6x squared over 10y plus 5. And there we have it, our final answer. 4x squared equals 2y to the third plus 4y. Well, what I want to do, I'm going to use implicit differentiation, and I'm going to treat everything the same except for like the y's. So 2 times 4, power comes down, we had a 8 here, x, subtract x by 1 to the first power. Same thing with the y's, but we're going to have a little extra step. 3 times 2 is 6, y, subtract x by 1, we have to the second power, times the derivative of y, which is dy dx. Plus, now, 4 being a constant, we kind of put out in front, 4 times, well, derivative of y is dy dx. We have 4 dy dx here. Now, what I want to do is I'm going to actually pull out a dy dx. I see it's being multiplied really here in both parts of that plus sign. So 8x here, oops, 8x is equal, so let's go pull out a dy dx out front, times what's left, right? 6y squared plus 4. Okay? So I made 6y squared plus 4 there, and dy dx right out front. Now, I can divide, since it's multiplication there, divide by 6y squared to both sides, 6y squared plus 4 to both sides, and then our final answer, we have dy dx by itself. So I'm going to put dy dx to the left now, so I like it like there, right there, 8x up top, over, when I'm dividing, 6y squared plus 4 to both sides, 6y squared plus 4 to both sides, and there we have it, our final answer. 5x to the third equals a negative 3xy plus 2. Well, what I want to do here, okay, is I want to derive this using implicit differentiation. The power rule comes down, 3 times 5 is 15, x squared is equal to, now this one's a little tricky, so what I'm going to do is I'm going to actually leave the negative 3 out front, okay, and I have x times y, okay, so what I actually have to do here is apply the product rule. So I have derivative of x, which is 1, times, a little 1 there, times y, plus x times the derivative of y, which is dy dx. Now luckily, we have just 2 on the outside, and the derivative of that is 0. So let me simplify this a little bit here. Let's multiply the 3 across, and the minus 3, or actually, let's just divide by negative 3 to both sides. Right now, let's just get it over with. So we're left with, well, divide by negative 3 on both sides, we have a negative 5x squared over here, equal to, well, 1 times y is y plus x dy dx. Okay? So I got that with a 3, it's fine. Now I'm going to subtract the y to both sides, okay? In doing so, I have negative 5x squared minus y equals x dy dx. Now what I can do is divide by x to both sides, giving me dy dx by itself. Okay, so I have, let's go fit that up here. So I have dy dx by itself here is equal to the numerator, which is at negative 5x squared minus y over x. Now, what some people might do is see that there's negative in both parts. You can pull that up front and make both of these a positive. Really up to you, but either way, we have the final answer here. Dy dx is equal to a negative 5x squared minus y over x. 1 equals 3x plus 2x squared y squared. Okay? Well, what I want to do is when I derive this, okay, on the left and right hand side, 1 on the left, easy, 0. Derivative of 3x on the right here, well, it's just 3 plus. And here is where it gets tricky. I'm going to put 2 as a constant out front. Now we have x squared times y squared. We're going to apply really a product rule here. Derivative of x squared is 2x, and we leave the y squared here. Plus now, leave x squared times the derivative of y squared, which is 2y, subtract x by 1, times, now y is being different, dy dx. Okay? So now from here, what you want to do is simplify if you can. So let's just go simplify this. Let's go multiply 2 across to distribute it. So we have 0 equals 3 plus 2 times 2 is 4. So we have 4xy squared plus 2 times this 2, and up front is 4. And we have x squared y dy dx. Okay? So now I'm kind of going to do a few things. I'm going to subtract a 3 to both sides and a 4x y squared to both sides. So I have negative 3 minus 4x y squared on the left equals 4x squared y dy dx. Okay. And there's multiplication between them. So what I'm going to do now is divide by y, or 4x squared y to both sides, leaving me dy dx by itself. So I'm going to write dy dx first. Write down first dy dx is equal to, this will be my numerator, negative 3 minus 4xy squared, all over my denominator, this part that I'm dividing both sides, 4x squared times y, and there we have it, our final answer. Dy dx is equal to negative 3 minus 4xy squared over 4x squared times 3x squared y squared equal to 4x squared minus 4xy. Okay, so what we want to do is we're going to derive the left and right hand side. Now the left hand side, we're going to use the product rule. So we have 3x squared, derivative of that part, 3x squared is 6x, subtract 1 times y squared, plus front part, 3x squared times derivative of y squared, which is 2y, subtract the exponent times dy dx. Now that's equal to the right-hand side. 2 times 4 is 8, so we have 8x minus, now I have to use the product rule again, okay? And this time I'm going to do the same way without really pulling out the 4 there, shoot 4x together as one unit. Derivative of 4x is 4, we have y left over plus, all right, now that subtraction is both there, plus, well, we have 4x times the derivative of y, which is just dy dx. Okay, so now we want to get dy dx's all to one side. That's our ultimate goal. The rest is just algebra here. So to do that, well, first let's go distribute this minus sign across to both all parts here, and then we're going to basically subtract. Well, let's go add this dy dx to this side, and then subtract the 6xy squared to the right hand side. So I'm going to leave this the same, 6xy squared here, plus 3x squared. Well, multiply 2 times 3, get that out of the way here. 2 times 3 being a 6. And then y times dy dx equals, let's just leave it here, 8x minus, well, minus 4y minus 4x dy dx. So like I said, let's go add 4x dy dx to the right hand side, and let's subtract the 6xy squared to the right, from the left hand side to the right hand side. So we have 6x squared y dy dx plus 4x dy dx equals, now we have here 8x minus 4y minus 6xy squared. Now I see I have dy dx on my left, everything else on the right. I'm going to pull out a dy dx. So I have dy dx here times, what will left be is 6x squared y plus 4x. And that's going to be equal to this part here, 8x minus 4y minus 6xy squared. Now I'm going to divide by 6x squared y plus 4x to both sides, leaving me dy dx by itself. So I'm going to write that kind of over here, but fit it all in. Dy dx is equal to, this being my numerator, 8x minus 4y minus 6xy squared, okay? All over my denominator, which is what I was dividing by, 6x squared y plus 4x. And there we have it, our final answer. Now, you might be able to simplify a little bit more, but it's fine as it is. 5x to the third plus xy squared is equal to 5x x to the third, y to the third. Okay? So from here, I'm going to derive both sides. Well, left-hand side is pretty easy. 5x to the third, 15x squared, plus here we use the product rule. Derivative of x is just 1. So we have 1 times y squared plus x times the derivative of y squared, which is 2y dy dx. Right-hand side, same thing, but let's go plot the 5 as a constant. Just leave it out there this time. Now we have 3x squared, y to the third, plus x to the third times 3y squared, right, times, for y, dy dx. Okay? All right. So now what we're going to do, let's go simplify this, and what I'm going to do is now I distribute that 5 across. Okay, so we have 15x squared plus y squared plus 2xy dy dx here on the left. Right-hand side, distribute the 5 to both parts, right? 5 times 3 is 15, so we have 15x squared y to the third plus, well, 5 times 3, this 3 is 15, 15x to the third y squared dy dx. So what I'm going to do is I'm going to bring all my dy dx's to one side and all my other stuff to the other side. So let's go put dy dx's to the left, everything else that's not attached to dy dx to the right. So doing so, I'm going to put 2xy up front here, 2xy dy dx, knowing that I'm going to subtract these two parts right there. Then I'm going to subtract this right here, minus 15x to the third y squared dy dx. All right. Now on the right-hand side, I'm left with, we have the 15x squared y to the third. Then I want to subtract these two parts, minus 15x squared minus y squared. And I should have everything. These two were over here. This one got put, came down, and it's 15x to the third y squared dy dx got over here. So let's go pull out the constant of dy dx. I know the constant, but it's in both parts, right? Dy dx both sides, or from both sides, both parts. Dy dx here is equal to, now I have, not equal to, pulling out multiplied by 2xy minus 15x to the third y squared. And that's equal to the right-hand side, which is leave there, 15x squared y to the third minus 15x squared minus y squared. So now I'm pretty much done. I'm just going to divide this whole parenthesis on both sides, and I have dy dx by itself. So dy dx by itself is equal to, now this is our numerator, 15x squared y to the third minus 15x squared minus y squared, all over my denominator, 2xy minus 15x to the third y squared. And that's good enough for me, so I might be able in the comment section below to tell you how to simplify this a little more, but I'm good as it is. 2x to the third equals 3xy plus 1 all squared. All right? So we're going to derive this. Well, let's focus on the left-hand side here. 2x to the third, 6x squared. Pretty easy. Now here we're going to have to apply the chain rule. So chain rule, 2 comes down, 2, keep the inside the same, 3xy plus 1. Subtract the exponent by 1, 2 minus 1 is 1. Now, we'll multiply that by the derivative of the inside. Now the inside, we have 3xy. So, multiplied by, well, let's just go put that 3 out front, coefficient, right, 3 times, and the derivative of xy, product, derivative of x is 1 times y, plus the x value, x times the derivative of y, which is dy dx. Don't really worry about that 1. I kind of pulled it out kind of early there, but don't really worry about the 1 because, well, derivative of 1 is 0. So now we're taking the derivative, we just need to get our dy dx by itself. Okay? So it's really up to you. I see a 2 and a 3 being multiplied, right? Times 3 here, and the 2 that's up front. That together gives me a 6. I divide that to both sides, leaving me with just an x squared by itself on the left. So let's go bring down what's left over, 3xy plus 1. Okay? Times, all right, and this whole thing would be multiplication, parentheses, so times, well, 1 times y is y plus x dy dx. So let's go bring everything over here, okay? over to the left. Now, this 3xy plus 1, all of that is actually together. I forgot to put parentheses there, right? Because we're multiplying all of that by this, okay? So, to do that, I'm going to divide by, well, this was a little tricky. I'm going to divide by 3xy plus 1. So we have x squared over 3xy plus 1 equals y plus x dy dx. Okay? Now, subtract y to both sides. All right, so we have x squared over 3xy plus 1 minus y is equal to x dy dx. Now, I'm going to divide by x to both sides, okay, divided by x to both sides, and this one actually kind of comes together. So we have dy over here, dy dx here, write that first, equals, divided by x to both sides. Well, when I have the x squared over 3xy plus 1 divided by an x, I always get confused on where do I put the x. And so I make a little note to myself, okay, if I have a divided by b divided by x, it's the same thing as a over b divided by x, which is the same thing as a over b times 1 over x. And it makes it a little easier to see. So here let's have x being multiplied by the denominator. Now, what's nice about that, if x is really just tossing down the denominator there, it cancels out with the x squared. So left with x over here, 3xy plus 1 equals minus y, remember divided by x to both parts, y over x. Now you could simplify this to be one fraction, and to be honest, if you had distributed, so I did a quick thing, but if you distributed the 2 across both parts and the 3 to both parts here, you wouldn't have that issue, and maybe I should have done that. But either way, we have a derivative, we have dy dx by itself, okay? And so we have dy dx is equal to x over 3xy plus 1 minus y over x. X squared is equal to, parentheses 4, x squared y to the third power plus 1 squared. Okay, so from there, you can derive this. Left-hand side is easy, is 2x. Right-hand side, power rule comes down. We're going to apply the chain rule, keep the inside the same. 4x squared y to the third plus 1. Exponent stays the same. Times now the derivative of the inside. Okay, derivative of the inside, I'm going to kind of pull that 4 out coefficient here. And then we have kind of a product, blank there, 2x times y to the third plus, keep the front part the same, x squared, right from there I pulled up 4, times 3y squared dy dx. And the derivative of 1, which is 0. So we're good there. So what I'm going to do is, let's go distribute now the 2 to both parts here, and the same thing with this 4. Let's go distribute that out. So we have 2x over here is equal to, okay, multiplying that out, I have 8x squared y to the third plus 2. Use that parentheses there, all that together, times this one here. Distribute the 4 across. 4 times 2 is 8. So we have 8x y to the third plus 4 times 3 is 12. 12x squared y squared dy dx. Okay, so I'm going to divide both sides by this. Okay, divide both sides by 8x squared y to the third plus 2, leaving me with 2x over 8x squared y to the third plus 2 equals all of this, 8x y to the third plus 12x squared y squared dy dx. Okay, I now can subtract this 8x y to the third to both sides, giving me this here by itself. And I'm going to, when I do that subtract, I'm going to rearrange it, giving me, I'm going to put this 12x squared y dy dx by itself first out front. So flipping around, 12x squared y squared dy dx is equal to 2x over 8x squared y to the third plus 2, okay, minus that 8x y to the third. Hope I can fit this in here. So I now just want to divide this 12x y squared to both sides, both parts, okay, leaving me dy dx by itself. So just kind of fit this in right here. dy dx is equal to, well, 2x stays up top, over, okay, multiply this 12, or dividing 12 to both sides goes in this denominator, okay, Oh, and 12 times 8. I should. My calculator says it's my phone. 12 times 8. Use a coefficient up front here. Okay, actually, let's just do it like this, make it easier. Not distribute that across. Okay, so we have 12 x squared y squared times what's left in the denominator, 8x squared y to the third plus 2. Okay, and then if I can fit that, minus, right? So this kind of comes down here. Don't forget that. So go over here, connect it all, or kind of all put together. But there's a minus sign here. Minus that kind of out of the way. So we have real estate here. I have the 8xy to the third over my denominator, which was that 12x squared y squared. And there we have it. Oh, final answer was kind of in 2 parts. Hopefully you can follow that and see that there. Now you can distribute that, and I was going to, but I was like, well, I might get it to half. So it's going to run out of room, so I went with it as it is. Sine of 2x to the second power, y to the third, equals 3x to the third plus 1. Okay. Now, I'm taking the sine of all of that. So let's go derive this using the kind of chain rule on the left-hand side. Derivative of sine is cosine. So cosine of, keep the inside the same, 2x squared y to the third, times the derivative of the inside. Now this is going to involve the product rule, right? Times, well, 2 down times 2 is 4, so we have 4x, so we have exponent by 1, so it's first power, y to the third, plus, well, 2x squared times the derivative of y to the third, which is 3y squared, times dy dx. Okay, that's equal to the right-hand side. This was a lot simpler. 3 times 3 is 9. 9x squared, don't worry about the 1. Derivative of 1 being 0. So now my whole goal is to get dy dx by itself. So to do that, I'm actually going to divide by cosine to both sides. Okay, so I have 4x y to the third plus, well, 2 times 3, we simplify this up a little bit. 2 times 3 being 6. 6x squared y squared dy dx equals 9x squared all over cosine of 2x squared y to the third. Now I'm going to subtract a 4x y to the third to both sides. Slowly getting there. So I have 6x squared y squared dy dx equals, bring this down, 9x squared over cosine of 2x squared y to the third minus, this is what came over, we're subtracting both sides, 4xy to the third. Lastly, we want to divide 6x squared y squared to both sides to get everything, to get dy dx by itself. So to do that, I have dy dx is equal to, well, 9x squared over, we multiply down here, 6x squared y squared cosine of 2x squared y to the third power minus 4xy to the third over 6x squared y squared. Now the essence of space, we could, well, I guess I could fit it here. I'm going to put it up here, right? Let's go simplify this a little bit. Hopefully I can fit it in there. All right, so the x's can cancel. X squareds can cancel out here. It's just simple simplification right there. 9 goes into, well, both divided by 3, so 3 and 2. Okay. Here, 1x cancels with this one. 2 of the y's cancel with all of that. And the 4 and 6 become 2 and 3. Okay? So when I write this, my final answer, dy dx, okay, is, well, we have 3 up top, 3 over 2y cosine of 2x squared y to the third, and that's cosines of all of that. Minus, here 2y up top, 2y over, cut off there, we're just left with 3x. Okay? Now there's probably a way, or I know there's a way, you can, get us all one fraction, but in the essence of space, I'm kind of stopping there. So we have our final answer of dy dx equals 3 over 2y cosine, or 2y squared, whoops, squared, 2y squared. Cosine of 2x, y to the third power, minus 2y over 3x. 3x squared plus 3 equals the natural log of 5xy squared. Well, the left-hand side's easy. Derive that, we have 6x, and we don't need plus 3, derivative of that is 0. Derivative of natural log, well, natural log is 1 over u prime. U being what's in this parentheses. So 1 over 5xy squared times the derivative of the parentheses. Now, derivative of the parentheses, we have the 5 on the outside. We'll do that coefficient. Derivative of x is just 1 times y squared plus, now the derivative of the product rule, we have x times 2y times dy dx. And that's what we want to get by itself. Now, the 5's can cancel here. Pretty easy to see that, do that, get that by itself. So what I'm going to do now is multiply both sides by xy squared. By doing that, it eliminates this. So I have, well, 6 times 6x times x is 6x squared and y squared equals all this, y squared plus, let's rearrange that to xy dy dx. Now we subtract the y squared on both sides, so we have 6x squared y squared minus y squared equals 2xy dy dx. Now all I have to do is divide 2xy on both sides, and then I'll dy dx by itself. So I'm going to do that, but I'm going to flip it, put dy dx first. So let's put that here, dy dx is equal to, this is my numerator, 6x squared minus y squared over this here, 2xy. And there we have it. Now, you could simplify this a little bit. The y's can cancel out some of those. Up to you. I'm pretty much fine as it is. So here we are. Oops, kind of cut through that x. It's all good. But our final answer, dy dx, is equal to 6x squared minus y squared over 2xy.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.